आज हम लोग पढ़ेंगे ट्रांसमिशन लाइन। ट्रांसमिशन लाइन तीन तरह से कैटेगराइज करा जा सकता है। पहला है शॉर्ट ट्रांसमिशन लाइन, सेकंड इज मीडियम ट्रांसमिशन लाइन एंड थर्ड इज लॉन्ग ट्रांसमिशन लाइन। शॉर्ट ट्रांसमिशन लाइन फ्रीक्वेंसी और लेंथ पे डिपेंड होता है। अगर फ्रीक्वेंसी 50 हर्ट्ज मान लें तो एलएफ का प्रोडक्ट अगर 80 इंटू 50 यानी 400 से कम है तो शॉर्ट ट्रांसमिशन के रेंज में आएगा। इट मीन्स इफ लेंथ हैज 80 किलो लेस देन 80 किलोमीटर देन वी कैन कॉल शॉर्ट ट्रांसमिशन लाइन। एल की वैल्यू कम होनी चाहिए 80 किलोमीटर से। एलएफ की वैल्यू कम होनी चाहिए 400 से। इट डिपेंड ऑन वेवलेंथ। शॉर्ट ट्रांसमिशन के लाइन के केस में चार्जिंग कैपेसिटर को नेगलेक्ट कर सकते हैं। यहाँ सी की वैल्यू हम 0 कर सकते हैं। Now we come to medium transmission line. When length is lies between 80 to 220, then we can call medium transmission line. It means LF is in between 80 to 50 to 220 into 50. In this case, you cannot neglect charging capacitor. You cannot neglect charging capacitor. Now we come to long transmission line. When length is greater than 220 किलोमीटर, जब लेंथ ट्रांसमिशन लाइन की लेंथ 220 किलोमीटर से ज़्यादा हो तो वो लॉन्ग ट्रांसमिशन लाइन के केस में आएगा। इट मीन्स प्रोडक्ट ऑफ फ्रीक्वेंसी एंड लेंथ विल बी 220 into 50 that will be greater than LF. In that case also you cannot neglect charging capacitor. Now we come to short transmission line. Consider this is a transmission line. Vs is sending end voltage, Vr is receiving end voltage, IR is receiving end current, IS is sending end current. From ABCD parameter we can say Vs is the sending end voltage, Is is sending end current, and this is ABCD constant, and this one is the Vr, IR receiving end voltage and receiving end current. This whole formula is two-port network. This is the two-port network. This is one is a first port and this one is a second port. We apply here two-port network. From this we open this matrix, multiply VR and IR by this matrix, then we get equation number 1 and second, this VR into A plus VR into B, IR into C plus IR into D. You can get this equation. In this, identity principle is applied, so the determinant will be 1. Determinant of this matrix, it means A, B, C, D, this determinant will be 1. It means AD into BC is equal to AD minus BC is equal to 1. AD minus BC is equal to 1. Now, we consider a practical transmission line having resistance R, inductance L, and sending end current IR, receiving end current IR, and sending end current IS, sending end voltage Vs, receiving end voltage VR. In that case, Vs will be equal to VR. Vs Is will be equal to IR. Now apply KVL on this loop. Apply KVL in this loop. In this IR current flow, then Vs will be Vs is equal to IR into R plus j omega L plus VR, and in this case Vs will be is equal to IR, so we can get this matrix Vs Is, and this one is Z, this one is Z, this is 1 Z and 0 1 VR IR. Now we come to phasor diagram of short transmission line in case of lagging power factor. If we consider phasor difference as VR, this is VR, and this is IR current लैग by VR by angle phi r एंगल से करंट लैग कर रहा है। अब हमें पता है कि voltage drop in case of resistance will be in phase of current. It means if this is the voltage drop across resistance, this is R and L, this is Vs and this is VR. If this is voltage drop across resistance, this is voltage drop across inductance, then this drop will be in phase of IR. This is the VR to draw here, and add the vector VR in parallel to IR. This is a parallel line, and add it in VR. Now we come to voltage drop across इंडक्टर। इंडक्टर में जो वोल्टेज ड्रॉप होता है वो करंट के डायरेक्टली परपेंडिकुलर होता है। हमने इस लाइन पे एक परपेंडिकुलर लाइन बनाया और इसको उठा के यहाँ पे हमने ऐड कर दिया, ये वी एल हो गया। और इन तीनों वेक्टर को हमने समेशन कर दिया एक लाइन से, इसको इस टेल को इस हेड से मिला दिया, ये वी एस मिल गया। दिस इज द फाई आर रिसीविंग एंड and this is the phi s sending end. For sending end, cos phi r is the receiving end PF power factor and cos phi s is the sending end power factor. Now if we divide in component of VR, this is VR, this angle is phi r, we want to divide this VR in their component, then this will be VR cos phi r and this will be VR sin phi r. Now if you consider x component and y component of this whole phasor diagram, then x component of VR will be VR cos phi r, and in this phase there is a IR into R, then add here IR into IR, and y component of VR will be VR into sin phi r, this is y component, and in this phase there is a vector IR into x, then add here IR into x. There are two components. If you want Vs, then x square plus y component square, take it under root, then you can get Vs. Apply here. Vs will be VR into cos phi r plus IR whole square plus VR into sin phi r plus IRX whole square under root. Taking some assumption, Vs will be VR plus IR cos phi r plus IRX sin phi r. For neglecting charging capacitor. Now you can get Vs minus VR is IR R cos phi r plus IR X sin phi r. If divided this whole equation divided by VR, then this will be voltage regulation. Voltage regulation. And this will be VR into R cos phi r plus IR into X sin phi r divided by VR. This is voltage regulation in case of lagging power factor. If you want get leading power factor, if you want get voltage regulation for leading power factor, then just we replace phi by minus phi. If you replace this phi by minus phi, then cos minus phi will be cos phi, but sin minus phi will be minus sin phi. Then you can get this. This is the voltage regulation in case of leading power factor. Zero voltage regulation is only possible in case of leading power factor. For this, we can get this is equal to 0, and if you equate 0, then VR IR cos phi r minus IR X sin phi r will be equal to 0. From this, we can get R cos phi r plus r cos phi r is equal to x sin phi r. From here you can get tan phi r is equal to r by x. This is the condition for zero voltage regulation. That's all.